double check your answers with mine. Did you have any questions about that? So once you're able to recognize what you need to do to both sides, the solving part should be a little easier for you. Go on to the next page and find any questions that look complex, you wouldn't be sure where to start, you want to go over together, any of those. Yes. Any of those we want to see, do go over, have questions about. 4, yep. 5, 4. Any others? We're not going to do 6 because it's going to be similar to 4 and 7. Any others before we move on? We'll start with those. So with number 4, anytime you see a fraction that equals another fraction, you're going to cross multiply. So that means multiply this numerator to this denominator, and then this numerator to the opposite denominator. I said that back. This denominator to the opposite numerator. So not multiply directly across, but diagonally. And when we do that, we can jump straight into the multiplication, or we can rewrite it first. That part doesn't matter. I'll rewrite it so we see what happened. You want to get it out of that fraction, so cross multiply to get it out of that fraction. And then it's like our regular problem. So our next step would be to distribute. And then previously, what we saw was doing this one step at a time. You can still do that one step at a time, but I'm going to show you how you can do that a little bit faster. We're going to do this twice, or 2 things at the same time simultaneously. So what do we want to move first? You guys choose whichever term.
45.
The 45 by itself? Or the 45x? Okay, so if we're moving the 45x, we're subtracting that to the other side. And if I'm moving the x's to the right, then I have to move the constants to the left, so I'm going to add 9 at the same time. So that 2 things cancel at the same time, the 45x's and the 9's. So I'm left with 54 equals, what is that? Negative, so again, 18. And then divide both sides by negative 8. So that x equals negative 3. Yes. To check yourself with these problems, you would do the same thing. You would put negative 3 into both sides, either the original or this, and see do both sides equal each other. Yes?
You have to completely write out the problem and do the fraction ones.
When you say completely write out the problem, what do you mean?
Well, in the beginning you said that we could just jump straight and multiply or completely write out this.
Yeah, so you could go from here to this step, but not to anything further. So you could either rewrite it first and then multiply, or jump into the multiplication. Okay. Other questions there? Okay. Number 5, similar to this step, we have something that we can distribute. So let's go ahead and do that on both sides. This part, we're just multiplying easy, 30m minus 18. Now this one, don't let the fraction confuse you. You can use your calculator. I will also say, if this were a problem that you were doing without calculator, if you have a fraction where the numerator is 1, you're really just going to divide the numbers. So I could say 24 divided by 3 is 8. 12 divided by 3 is 4. Now you can double check that as well. Okay, what do we want to move first? If I'm subtracting 8m, I'm going to move 18 over to the right at the same time. Again, if you would rather see them in 2 separate steps, that's fine. So that we have 22m equals 22. And when I divide both sides by 22, m is what? 1. Correct. Questions on that one?
How do we know which side to subtract?
It doesn't matter. You can pick whichever one you want. You just have to do the opposite. So let's say I moved 8m over, but then I also moved 4 over, just so you see what happens.
So what would be the difference on instead of subtracting 8m,
You would get negative 22 equals negative 22, which would still give you a positive. But, so that one would be fine if you switched them and did the opposites here. But if you move 2 of the same thing to the same side, this is what would happen. If you move 2 of the same things from the same side to the opposite side, then you're left with 0. You created an extra step. Now you have to move something back and then solve. So be mindful of that. Don't try to avoid doing that. Yes?
Where did you get the 18 from?
Multiply 6 and negative 3. Okay. For number 7, how would we start that since it's a fraction that equals another fraction? Cross multiply, yes. So that should be your answer every single time you see a problem like this. I keep trying to change this color. It's just not what I have. So again, I rewrote it, but you could have went straight into multiplying 3b minus 9 equals 8b minus 32. What do we want to move there? Sure. We can move the 9 by adding, and I'll move the 8 by subtracting. If you did the opposites, that's fine. What was that, 27, 28? What was that, 27, 28? My brain is not subtracting correctly. What was that number? Double check that for me. Oh, 23. I was like, that's not right. Okay. So sometimes when you solve this, you'll get a decimal or a fraction. Sometimes you will get that by accident, so be careful. Now this one would give us a nice decimal. So we could put 4.6 if you so choose. You could leave it as a fraction. But if you got a repeating number or repeating decimal, I would leave it as a fraction. Questions on that one? So we're going to talk about two other types of special case problems that we'll try really quickly on the next page. So you won't really notice it's a special case until you start to solve it, and then something should stick out to you that will tell you, okay, this is going to be one of my special cases, and then I'll show you what that looks like. So let's start solving this like normal. I would first distribute. And combine like terms. Now, before we start moving things, what do we notice about this? What stands out? Does anything stand out?
Yeah.
What?
There will be no x. X will be 0.
If you're continue to solve it, yes. But what about just right now, just looking at this? Is there anything similar or different?
Yeah.
They both have a 5 for the x. That should tell you this is going to be a special case, but also that these are different. So let's say we keep going and we solve this, and I subtract 5x and move the 5. So exactly what I talked about earlier, this entire side cancels, becomes 0. But also, these also cancel. I don't have x anymore. And I get something like this. Is this a true statement? No. So when this happens, when your variables cancel each other out and you're left with something that's not a true statement, this is no solution. So if you were checking this answer algebraically, any number you put in, so I'll move this, you don't have to write this because it's at the top as well, but oh, actually I forgot that I copied it like that so it won't move. But if you were checking this algebraically, you can put in whatever number you want, but no number would ever work. I could put in 1, 10, 100, million, all of the numbers in between, nothing would ever work. And I'll show you what that looks like in a minute. Now you could get no solution by accident, so be careful. Questions on that? Okay, let's try number 2. Same process, go ahead and distribute. And combine the terms. Before we keep going, what stands out about this? Maddie? Yes. Yes. Both sides are exactly the same. So when you get something that looks like that, that should stand out or bells should go off. This is going to be a special case. So if we keep going and we keep solving, let's say I get rid of 6b and I get rid of 10. What happens? 0 equals 0. Everything cancels each other out. But is this a true statement? Yes. So when your variables cancel and you get a true statement, this is infinitely many solutions. So the opposite of no solution, where no number would ever work, infinitely many, you can put in every single number you want, no, into x, b, whatever the variable is, and it will always work. So I could put in 1 and it would work, I can put in 10, it would work, 100, 1,000,000, 5,000, all of them would work. Okay. Questions on that? Now, I will say, if you get to this step and you recognize these are the same but these are different, that's going to be no solution. From there, if you remember that, you can stop. Same thing here, if you get to this and it's the same and you remember, this is going to be infinitely many solutions, or IMS, you could stop. But if you forget that, keep going, and you need to know the differences between these two. Okay. I want you to try 3 and 4. I want you to try 3 and 4. Which type of solution did we find number 3 to be? Infinitely many. Does anyone need to see that one worked out? Okay. What about number 4? I heard it, but not really. No solution. Does anyone need to see that one worked out? Yes, okay. Okay, so for this one, we could combine like terms, either algebraically by making this a fraction, multiplying both by 5, and changing that, or you can do that in your calculator, and then subtracting them. What was that? That's my shoe. So if you had changed the fractions, this would be 10 over 5, and then that would be 12 minus 10 to give you 2 this. Now, from this, I can see we have the same coefficient, the number in front of the variable, but different constants. At that point, you could say it's no solution. But if you kept going, I could have subtracted the variable term and added one of the constant terms. So we would have got 0 equals 10, which is not a solution. Questions on that? I just want to do one of the problems on the back and then show you how to check this in Desmos. And then you guys will have time to practice Delta Math and other things. So we'll do number 1. So find the value of x so that the rectangles have the same area. First off, we need to figure out how do we find area of a rectangle. So not perimeter, but area. What is that? Yes, multiply the length and the width. And then if they have the same area, well, first, I know the area of this is going to be 12x. I know the area of this, if I multiply them, will be 16 times x minus 2. If they have the same area, how would I set up this equation? Not square it. I need something that tells me this is an equation. The equal sign in between. Okay, so put that equal sign in between, and then we can solve that. I see. By distributing, I could move the 16x over. And divide both sides by the negative 1. Now, we just needed to find the value of x, but because we know the value of x, if it asked us to, we could actually find the area as well. Because if I put 8 in here and I multiply 12 and 8, what would that area be? Oh, if I put 8 in for x, and I found the area by multiplying these two, what would that area be? 96. Units, whatever it is. means this one would also be 96 units. So that's 16 times 6 is 96. If you were to get word problems in general, you shouldn't be getting negative numbers. So like area can't be negative. The distance, the width, the length can't be negative. If you're looking for a cost of something, you're usually not going to get a negative unless you're subtracting in that sense, but not normally. So just pay attention to those things. Okay, so you do have delta math on this. This is the formative one that's due on Friday. If you didn't finish the word problems and multi-step that you may have started on Monday, the word problems formative, the other one informative, you will work on that. The discussion for multi-step is due today. I'm going to show you really quickly how to check this in Desmos. If I could get something. Okay, so for your anything that has a solution, if you have variables on both sides, you'll get that line like we did before. But for your infinitely many and no solutions, I'm just going to type in something random here. So if you have a no solution case, no matter how far you zoom in, there will be nothing that appears. But if you know that, that will tell you it's a special case. You could put those in separately. And they'll give you two separate lines that will not cross over or anything. So that would tell you that's a no solution case. But if you had infinitely many, if you put that all in, again, you'll get nothing there. But if you put them in as two separate lines, I'm not sure if you saw what happened just then, but they overlap. So if it's infinitely many, they will overlap. So that's a great way to double check yourself in Desmos. Okay, you guys can work on Delta Math, move around, let me